Right, we are starting 6-4 today, and our learning goal is I can find percents of change in quantities. So I'm going to have you do the warm-up, and then you'll check your answer with mine. All right, so for number 1, our constant of proportionality is always our number next to x, because it's y equals kx. And so our constant of proportionality is our 2. And for number 2, our constant of proportionality was 3. Whenever you're writing a decimal as a percent, you multiply it by 100, or you just move the decimal over 2 places to the right. So you get 45% and 134%. All right, so we are looking at percent of change. Percent of change is the percent that a quantity changes from the original amount. So the percent of change is the amount of change divided by the original change. The percent of increase is the original amount increase. So the percent of change is called the percent of increase. So percent of increase is going to be our new amount minus our old amount divided by our old amount. Percent of decrease is when the original amount decreases. The percent of change is called the percent of decrease. And so this is the old amount minus the new amount, all divided by the old amount. All right, so we're going to start with finding the percent of increase. The table shows the number of hours you spent online last weekend. What is the percent change in your time spent online from Saturday to Sunday? So our new amount would be our newer day, so the closest day to today, which is Sunday. And so this would be 4.5 minus our original amount. So this is our new. This is our old because Saturday came before Sunday. And then we divide that by our old amount, which was 2. And so you're going to do 4.5 minus 2. You have to hit enter first or else it won't know the order of operations. So we get 2.5 divided by 2. And then you can divide that answer by 2, and we get 1 and 25 hundredths. This, however, is not a percent. So we have to then take this number and multiply by 100. And that gives us our percent of increase, which is 125%. This makes sense because we more than doubled our amount of hours online. So we went from 2 to 4.5. And had we just doubled it, then that would have just been the 4. And it had been 4 hours, then it would have been 100%. Because we went more than 4, more than doubling our previous day, it increased us to 125% increase. To find the percent of change and round it to the nearest tenth for numbers 1 and 2, and then I want you to compare your answer with mine. All right, for number 1, 10 inches is our old, 25 is our new, so we're going to do 25 minus 10, all divided by 10, and we get 15 divided by 10, which equals 1.5, and we multiply that by 100, and we get 150. That makes sense because if we doubled 10, then that would give us 20, and that would have been our 100%. But since we went more than 20, we know that it's going to be bigger than 100%. Over here, we went from 57 people to 65 people. And so 65 is our new, which means that we are going to do 65 minus 57, and we get 8, and then divide that by 57. When you divide it by 57, you're going to get a long decimal, and that's okay. Before you round it to the nearest tenth, you need to multiply it by 100 first. And so you're going to multiply by 100 first, and then you'll round it to the nearest decimal because we are looking for the decimal of the percent, not the number itself, like not the rational number itself. So we get 14.0%. Now we're going to find the percent of decrease. So the only thing that's different about this equation is that our original comes first. The reason we do this is so that way we don't get a negative. If we're decreasing in something, that means that our original amount was more than our new amount. And so when we subtract the two, we want to do big minus small. And so we should never get a negative percent. And that's why we had to switch it to make our original number come first. So it says the bar graph shows softball players' home run totals. What was the percent of change from 2016? So this is our old to 2017. So this is our new. So we went from 28 to 20, and then we divide by 28 because that's our original. So we get 8 divided by 28. And then we multiply that by 100. And so now let's just round it to the nearest tenth. So we get 28.6 because that 7 makes that 5 round up. So that means that the softball players' total home runs decreased 28% from 2016 to 2017. That tells us that they had more home runs in 2016. So I want you to try example 3, and then I want you to check your answer with mine. So in example 2, what was the percent of change from 2014 to 2015? So because it doesn't tell us it's a percent decrease, we have to look on our own to see if it's going to increase or decrease. So 2014 we had 18, 2010 or 2015 we had 10. So we know it's going to be percent of decrease. So we're going to do our old minus our new, all divided by our old. So 18 minus 10 divided by 18. We get 8 divided by 18, which gives us a 44.4% decrease. It's important for you to add this part, because if you didn't, since the word problem itself never said that it was decreasing, if you only gave this part, nobody would know what you're talking about. They wouldn't know if they did better or worse that year, or it's not in context with what is happening on the graph. So you have to tell them that it is a 44% decrease. All right, so percent of error is the estimated amount, differs from the actual amount. So a lot of companies actually use percent error to make sure that their products are as good as they say that they are. And so typically we want our percent of error to be really, 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 really small. And that way customers can't come back with lawsuits. So percent of error is when we have the amount of the error divided by the actual amount. All right, so you fill bags with about 16 ounces of homemade dog treats. The acceptable percent error when filling the bag is 5%. Tell whether the bag is acceptable. So we have dog bag A, and we have bag B. So the amount of error is going to be our 16, which we know is how much it should be, about 16 ounces, minus what dog bag A actually is. And that gives us 1. And we're going to take that and we're going to divide that by the actual amount that should be in the bag. So we know it should be 16. So we have 1 divided by 16. 1 divided by 16. And then we're going to multiply that by 100 because we want a percent. So we get 6.25% of air. In bag B, our amount of air is the 16.5 minus 16. We just want it to be a positive number, so over here you'll see that I did 16 minus 15. You just always take the big number minus the small number divided by our actual that should be in the bag. And so we have 0.5 over 16 times 100. So we have 3.125% of air. And so you will notice that since dog bag A is bigger than 5%, this is not acceptable. And that's because this is bigger than 5%. Dog bag B is acceptable because this is less than the 5%. And so this one is acceptable. They do this a lot with when they're testing and like selling out bags of like chips and stuff like that. You'll notice sometimes the bag of chips, it's not full all the way. That's because they didn't meet the percent of air. There have been people who have checked double stuffed Oreos to see if they're actually double stuffed. And so they have to make sure that they're following this percent of air, or else they could actually get sued, which actually has happened. So I'm going to have you complete the closure, and then you can start your homework. We are going to check notes next class.